Hi, welcome to this Corbettmaths video. In this video we're going to look at the GCSE Further Maths topic of differentiation, and we're going to look at differentiation that involves fractions. Now whenever I say it involves fractions, for GCSE Further Maths the power will always be an integer, so the fraction that I'm talking about will be the coefficient, the number in front of the thing that you're differentiating. Now we looked at in our last video on differentiation that if we had y is equal to x to the power of n, that when we differentiate it we find dy by dx, which is the gradient function, and that's equal to n times x to the power of n minus 1. In other words, you bring down the power and you reduce the power by 1. So we're going to look at some questions now that whenever we're given y, there's a coefficient that's a fraction, and we're going to look at how we would differentiate those, which is the same technique, which is you bring down the power, you times with the coefficient by the power, and then you reduce the power by 1. Okay, let's have a look at our first example. So our first question, we've got that y is equal to half x to the power of 6. And we've been asked to find dy by dx, so we want to differentiate this. Okay, so we've got y is equal to a half x to the power of 6, or a half multiplied by x to the power of 6. If we wanted to differentiate this, we bring down the power, so we'll get dy by dx. Whenever we differentiate, we get dy by dx, which is the gradient function. We would bring down the power, which means in this case we're going to times what's in front of it by 6. So a half times 6, so a half times 6 will be equal to 3, because if you get 6 halves, that's equal to 3. Now also remember the GCSE Further Maths is a calculator paper, so you could do that on your calculator if you wanted to. You could do a half times 6. Now, that's quite a nice one, but if you've got a fraction and a power that are a bit trickier, just remember you can use your calculator to work it out. So a half times 6 is equal to 3, so we're going to put 3 at the front there, and then we've got x, and then we're going to reduce the power by 1. So the power was 6, we're going to take 1 away from that, so it'll then be 5. So that means that dy by dx is equal to 3x to the power of 5. And that's it. So if we were given that y is equal to a half x to the power of 6, dy by dx would be equal to 3x to the power of 5. We've brought down the power, and then we've reduced the power by 1. Okay, let's have a look at our next question. So our next question, we've been given that y is equal to 3/4 x to the power of 8, and we've been asked to find dy by dx. So we've been asked to differentiate this. So we know that y is equal to 3/4 x to the power of 8, and we want to differentiate it, which means we want to bring down the power. So we're going to times this coefficient by 8, and then we're going to then reduce the power by 1. Okay, so we've got y. When we differentiate, we're going to get dy by dx. So dy by dx, the gradient function, and that's equal to, and then we're going to bring down the power and we're going to times this coefficient by 8. So we're going to do 3/4 times 8. So we're going to do 3/4 multiplied by 8. Now remember again, GCSE Further Maths is a calculator paper, so you could do that on your calculator if you wanted to, but actually we can just work out 3/4 of 8, and 3/4 of 8 is 6. So that's equal to 6. So that would be equal to 6 x to the power of, and then you're going to reduce the power by 1. It was 8. When you take away 1, you'll then get 7. So that means that dy by dx is equal to 6x to the power of 7, and that's it. Okay, let's look at our next question. Okay, this time we've got that y is equal to 3/5 x to the power of 4, and we've been asked to find dy by dx. So again, we've got y is equal to 3/5 x to the power of 4. So to differentiate this, we're going to bring down the power, we're going to times the coefficient by that whole power, and then we're going to reduce the power by 1. So when we differentiate, we get dy by dx, and that's equal to, we're going to bring down the power, so we're going to multiply the 3/5 by 4, so we're going to do 3/5 times 4. And if we've got 3/5 and we times it by 4, I tend to just put 4 over 1 like that, and then I do 3 times 4 is equal to 12, and then 5 times 1 is equal to 5. So 3/5 times 4 would be equal to 12/5. Now again, remember the GCSE Further Maths is a calculator paper, and you can do that in the calculator if you wanted to. You could just do 3/5 times 4, but it's just handy to be able to differentiate without having to grab your calculator to do that multiplication. So 3/5 multiplied by 4 is equal to 12/5. So we've got 12/5. So when we multiply the coefficient by the whole power, we get 12/5. Then we've got x, and then we're going to reduce the power by 1. It was 4. When you take away 1, you get 3. So that means that if y is equal to 3/5 x to the power of 4, dy by dx is equal to 12/5 x to the power of 3, or x cubed. And that's it. Okay, let's have a look at our next example. Now, our next example, I've chosen this one on purpose because I want to show you that sometimes you may encounter these fractions in a slightly different format. So if we were given that y is equal to a third x to the power of 6, and we wanted to find dy by dx, well, we would differentiate it. So we get dy by dx is equal to, we would then bring down the power. So we would do a third multiplied by 6, and a third multiplied by 6. Well, a third multiplied by 6 is equal to 2, because a third of 6 is 2, so that's 2. And then we've got x to the power of, and then we're going to reduce the power by 1. So it was 6, you take away 1, you then get 5. So if we know that y is equal to a third x to the power of 6, when we differentiate it, we get dy by dx is equal to 2x to the power 5. Now, I've chosen this example on purpose because I want to show you that actually you might encounter this in a different format. So I'm just going to move our answer down there for the minute, and I'm just going to get rid of that for a second. And let's have a look at this format here. So we've got the y is equal to x to the power of 6 over 3. So this looks a bit different than this, but it's actually the same. So if you've got a third multiplied by x to the power of 6, it's actually the same as x to the power of 6 divided by 3. Now, there's a couple of ways to think about it. If you multiply something by a third, it's the same as dividing it by 3. So for instance, a third times 15 is 5, and 15 divided by 3 is equal to 5. So that's one way to think about it. Another way to think about it is if we had, for instance, a quarter multiplied by w, so quarter w. So that's a quarter w. So something similar to that format. If we had a quarter w, that's the same as a quarter times w. And then w is the same as w over 1, so we've got a quarter times w over 1. And then if we times the numerators together and the denominators together, what do we get? Well, 1 times w is w, and 4 times 1 is equal to 4. So a quarter w is the same as w over 4. So those two are equivalent to each other. So quarter w and w over 4, they're equivalent to each other. So if we have a look at this question here, well, if I was given this to differentiate, what I would do is I would write it out as y equals, and instead of writing x to the power of 6 over 3, I would actually write it as a third x to the power of 6, because x to the power of 6 over 3 is the same as a third of x to the power of 6. You can actually just bring that fraction out in front of the x to the power of 6. And now we've brought the fraction out, we've written a third of x to the power of 6, then you could differentiate it to get the dy by dx is equal to, and then you could times the coefficient by the power, a third times 6, as we've seen, is equal to 2, and then you could reduce the power by 1, so to the power of 5. And that's it. So just to show you that if you've got a third x to the power of 6, that's the same as x to the power of 6 over 3. So it's actually quite useful to be able to take something in this format and to write it in that format, especially whenever you want to differentiate it. Okay, let's have a look at another example. Okay, so here's another one. If we had y is equal to 2/5 x to the power of 10, this could be written in a different format. It could actually be written in this format here, and you might actually encounter a question where it's shown as this, where you've got y is equal to 2x to the power of 10 on the numerator, and then over 5. And then if you had something like this, you could actually just bring the fraction out in front. So you could actually just bring the 2/5 out in front of the x to the power of 10. So you could write it as 2/5 x to the power of 10. And I find that a lot easier to differentiate than that, because you've got the coefficient, the thing in the front, you've got the power, and then you can just times the 2/5 by 10 and then reduce the power by 1. So if it was in this format, I would write it as that. And just to show you that if you had 2/5 multiplied by x to the power of 10, that's the same as 10 over 1. When you multiply, you'd get 2x to the power of 10 over 5, which is the same as what you had. So that's why you can just bring that fraction out in front. And that's it. Okay, so now we've written in a nice format, in this format here. Now let's just differentiate it. So dy by dx is equal to, let's times the coefficient by the old power. So we're going to do 2/5 times 10, and 2/5 multiplied by 10. Well, that'd be 20/5, or that's equal to 4, or you can do 2/5 of 10, and that's equal to 4 as well. So that's 4. So 4, and then x to the power of, and then let's reduce the power by 1. It was 10. When you take away 1, you get 9. So that means that dy by dx is equal to 4x to the power of 9. And that's it. So if you're ever given a question like this, where we've got the fraction and we've got the variable on the numerator, you can just bring that fraction out in front of the x and then differentiate it. Okay, let's look at our next question. Okay, so our next question, we've been given that y is equal to x to the power of 8 over 2 plus x to the power of 3 over 3, and we've been asked to find dy by dx. Okay, so if we have a look at this, I'm going to just rearrange it slightly before we differentiate it. So I'm going to write y equals, and instead of writing x to the power of 8 over 2, well, that's the same as a half of x to the power of 8. So half of x to the power of 8, because dividing by 2 is the same as multiplying by half. And then plus, and then here, instead of writing x to the power of 3 over 3, I'm going to write it as a third of x to the power of 3. And now we can differentiate this nicely. So dy by dx would be equal to, let's bring down the power, a half multiplied by 8 would be equal to 4, so you get 4, and then x to the power of, and then when we reduce the power by 1, we'll get 7. So when we differentiate a half x to the power of 8, we get 4x to the power of 7. Okay, so now let's differentiate this, a third x cubed. So we'll bring down the power, a third times 3 is equal to 1. So I'm just going to write plus, I'm not going to write plus 1, because we've then got the x term, and we're going to reduce the power by 1. So instead of being cubed, it's going to be squared. So that's it, so x squared. So if you had a third x to the power of 3, or a third x cubed, and you differentiate it, you get x squared. And that's it. So that's it, we've differentiated. So in this question, whenever we had these fractions, it just made it a bit easier to bring that fraction out in front of the x terms that were on the numerator. So half of x to the power of 8 and a third of x cubed. Okay, and let's look at our last example. Okay, so our last question, we've got y is equal to 3/8 x to the power 4, subtract x plus 9, and we've been asked to find dy by dx. So we've got y is equal to 3/8 x to the power 4. Well, that's quite nice, the format they've given it to us in. Subtract x plus 9. So that's fantastic. This is what y is equal to. Now let's differentiate. So when we differentiate it, we get dy by dx. We're going to multiply the coefficient by the whole power, so we're going to do 3/8 times 4. Remember, it is a calculator question, so you can just do 3/8 times 4 in your calculator if you wanted to, or if you just wanted to do it manually, or you can just call that 4 over 1. And 3 times 4 is equal to 12, and 8 times 1 is equal to 8. And then we can cancel down 12/8. We can divide both the numerator and denominator by 4, and we get 3/2. So that means that when we take the 3/8 and times it by 4, we get 3/2. So we've got 3/2, and then x, and then we're going to reduce the power by 1. So instead of it being 4, it's now going to be 3. Okay, so we've differentiated the first term, the one with the fraction. Now the rest of it's quite straightforward. We want to differentiate minus x, that's minus 1x. And when we differentiate minus 1x, we'll just get minus 1. Think back to your last video. If you're differentiating 8x, you get 8. If you're differentiating 10x, you get 10. If you differentiate minus 4x, you get minus 4. If you differentiate minus 1x or minus x, you're going to get minus 1. And when you differentiate numbers such as plus 9 here, you're just going to get 0. So that's it. That's our answer. And that's it. So in this video, we've looked at the GCSE Further Maths topic of differentiation, and we've looked at how to differentiate whenever fractions are involved. Now in our next video, we're going to look at how to answer differentiation questions where there's x's or variables on the denominator. So we're going to look at how we deal with those. And that's it.